So we're on page 3, this second question here. Who remembers what these things are? Absolute value. And what does that do? Yeah, distance from 0. Nice. Do they care? What is the answer always going to be? It's going to be positive, right? So in the meantime, though, I don't want those bars to confuse you at the beginning. They're actually technically just kind of act as parentheses until you just have one number in there. So don't do anything different until you just have one number in there. So if we're trying to find g of 9, let's go plug in that 9. So we've got these bars, and we've had 6 times 9 minus 77, not doing anything with the bars. What's 6 times 9 without that calculator? 54 minus 77 without that calculator. Toby. Well, all right, so we've got negative 23. Now that I've got one number in there, now I can pay attention to those bars. What's the absolute value of negative 23? Boom, we're done. What if this in here said, what's the absolute value of 23? It would still be 23, okay? We don't change it. It just makes sure that it becomes positive. We okay with that? A little dusty, those cobwebs. Okay. Let's go over here. Ooh, lots going on over here. Lots going on. J of x is 3x squared minus x. Again, there is an x there, x there, x there. Now, what do I need to do with the c minus 5? To every single x, right? And c minus 5, that has 2 terms. What do I need to do? I just need to be mindful. Yeah, I got to put in parentheses. So I'd have a c minus 5 squared minus, this is where a lot of people make mistakes. Parenthesis or no parenthesis? Got to put parentheses. Minus c minus 5, because they're saying subtract that quantity. And if I didn't put parentheses, I would have written minus c minus 5 like that. I wouldn't have put parentheses. Is that equivalent to this? What happens when I distribute that? Negative c plus 5, right? That's not the same. So this is no good up here. Okay, so we will come to that, negative c plus 5. But what about this over here? This is kind of annoying too.
All freshmen that have not had your picture.
So we just need to make sure that we don't just say, oh, this is going to be c squared plus 25. Because it's not. We got to make sure that we distribute that through as c minus 5 times c minus 5. That's a crucial step. Then we've got, just as we've talked, distributing my minus c plus 5 plus 4. Then at this point, I'm going to go distribute. I'm going to just leave my 3 chilling. I'm going to leave my 3, and I have a c squared minus how many c's? What's that one going to get me? Minus 5c minus 5 more c, getting me how many c's right here? Minus 10 c's. Good job, you guys. Plus or minus 25? Plus 25. And then my minus c plus 5 plus 4. Actually, I'm just going to combine my plus 5 plus 4. Plus 5 plus 4 is just going to get me a 9. Now I'm finally going to distribute my 3. And I got a little 3c squared minus 30c plus 75. Feel free to shout out anything, guys. Minus c plus 9. Okay, you guys, when we combine like terms, we got negative 30c minus 1c. Negative 29 or negative 31? Nice. Negative 31. C. 75 plus 9. Good. And we're done there. Whew. But those were 2 big things I was truly trying to trick you with. That squaring as well as distributing that negative. It says state the domain and range of these. Now these, we did that on the front, but these look a little bit more complicated because they are. It says state the domain and range. The denominator can never be what? What can a denominator never equal? Or my function just doesn't exist. 0. Exactly. My denominator can never be 0. And a square root always needs to be positive. So let's just focus on this first one. Do you agree something's going on my graph? My graph is all good until like something's going on here. And then my graph is good and then something's going on here. Does anyone remember what those are called? A hole would look like this. If I just had a random literal hole in my graph. An asymptote. What kind of one? Vertical asymptote. A vertical asymptote. And our job right now is to figure out where do we have vertical asymptotes. Well, vertical asymptotes, if I were you, I'd write myself a little note. A vertical asymptote, that is the very strange word. Asymptote is when the denominator is 0. Okay, so let's go figure out where our vertical asymptote is on this one. I often write VA for vertical asymptote just so I can use some shorthand. When does that denominator, x squared minus 4, equal 0? And we can just solve that like a basic equation. What would we do first?
X squared minus 4 equals 0.
Yeah, and then how would I start getting that x by itself? Yeah, let's move that 4 over, and then what? You know it, let's square root it. Square root of 4. 2 or? Nice. So we could say plus or minus 2, and it does make sense. We do have 2 vertical asymptotes here, one at -2, and if I were you, I would go draw that in, and one at +2. Your graphing calculator won't draw them in for you, so I think it's helpful to draw it in if I'm trying to write my domain and range. A word that you've probably never heard before that I often use for plus or minus is plyness. I just think it's a funny little memory thing. Mr. Richards would never use it. Miss Meister hates it. I think it's funny. Plyness too. Okay, plus or minus. Okay, so what would be my domain? Let's talk about domain. Domain is for what x values does the graph exist? For what x values does the graph exist? And domain is always left to right. So how far left do you think this graph is going? Negative infinity, I dig it, Jackson. Until, this is funky, we haven't done this. I'm going to highlight, okay, ready? I'm on the graph, I'm on the graph, I'm on the graph. Where does my domain stop there? At that vertical asymptote, right? So I'm going to say negative infinity to -2. Will I ever equal -2 if there's a vertical asymptote? I get really, really close to it, but you'll never equal it because if I equaled -2, -2 squared is 4, 4 minus 4 is 0. I'd have a 0 in the denominator. Can't do it. So we're going to say a parenthesis there. We're going to get really close to that -2. And this right here, I'm going to highlight it, is shown here on my graph. Then let's go show this blue part. What is the domain for this blue part, do you think? From what x to what x do you think that goes from? -2 to 2. Fick is so good. I'm going to say a little union. I use parentheses on my -2 and my 2 because, again, we can never equal a vertical asymptote. But Fick was saying, all right, I'm coming in on the other side of this -2, and I'm going to this vertical asymptote, which is +2. So good. Then I've got one more, and I'm going to do it in purple. This portion of the graph that I got to describe its I've got to describe its domain. So I'm going to say union. From what x to what x am I on this part of the graph? What? Yeah, I pick up on the other side of this 2 vertical asymptote, and I'm going all the way to the right, which would be infinity. 2 to infinity. Whew, that's a lot. My range then asks, how low to how high? How low to how high? How low do you think it's going? Bless you, Tobe. How low? Would you agree we're going all the way down? Okay, we're going to -infinity. How high do you think we're going? Yeah, do you agree that this middle portion doesn't stop? I'm going to make this very visible, what I'm talking about. I'm going to go, whoo. Do you agree this goes -infinity to infinity, no gaps? If I were to say, well, what about this -infinity to, I don't know how high that goes, like negative, I don't know, let's say 7 maybe. If you were to stop and say -infinity to -7, and then -7 to 7, and then 7 to infinity, we're kind of being redundant again. This -infinity to infinity takes care of it all. My bad, I should not have put a parenthesis there. -infinity to infinity. To infinity. Whoa, still on the fat pen. To infinity. Boop. This denominator now has a square root. But my denominators can't be 0. That's for my vertical asymptote. So I still want you guys to say, when does square root of x minus 4 equal 0? What would you do first to solve that one? am I getting rid of that square root? Exactly. We're squaring. What's 0 squared? 0. Square root squared? Cancels out. And what am I left with over here? Yes, thank you. Let's go solve it. How did I get x by itself then? Perf. Okay, I do want you guys to, you wouldn't have known this, give yourself an open circle up here, and I want us to go label that hole. I made it open for a reason. That hole is going to be 4, and then let's go ahead and make it like 3.5. I can't quite remember. And then this is straight up from my graphing calculator, and even though it looks like it's cut off, this is doing this. Boop. It's doing that. If you're like, what is going on? It is continuing. Okay, let's talk domain. Let's talk range. My domain. From what x do we start at? And which x are we going to? What do you think? 4 to what x? So good. 4 with a parenthesis or bracket if I made that a hole up here. Parenthesis. So we're going from 4 to infinity. My range, how low to how high on my y-axis. Just as a reminder, square root graphs, they will constantly continue to go down, 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 or up, up, up. So you might be like, oh, is it starting to level off? Nope, it will continuously, slowly go down. So how low do you think this is going? Negative infinity up to negative infinity to 3.5 parenthesis or bracket. Parenthesis, good job.